gravitational force. This is the attractive force existing between any two objects. It is a universal force. Every object in the universe experiences this force due to other objects. Larger objects always exert this force on smaller objects. For example, when we throw a stone upwards from Earth, it falls down to the Earth due to the gravitational force of Earth. In a similar way, the Moon is orbiting around the Earth due to the gravitational force of the Earth. Planets are orbiting around the Sun due to the gravitational force of the Sun. Newton's law of gravitation. We are used to calculating the Earth's gravitational force on objects in everyday life. Newton's second law of motion. Formula: F is equal to mg, where F is equal to force pulling objects toward the Earth, m is equal to mass of the object, g is equal to the acceleration due to gravity. This number is a constant for all masses of matter. But this is just a simplified version of the actual law of gravitation, which states that any two objects attract each other with a force. The gravitational force formula, where F is equal to gravitational force, G is equal to 6.67 times 10 raised to negative 11 Newton kilograms squared over meter squared. M1 is equal to mass of first object in kilograms. M2 is equal to mass of second object in kilograms. R is equal to the distance between objects in meters. The friction force is a force exerted by a surface as an object moves across it or makes an effort to move across it. There are at least two types of friction force: the sliding and static friction. Though it is not always the case, the friction force often opposes the motion of an object. Friction results from the two surfaces being pressed together closely, causing intermolecular attractive forces between molecules of different surfaces. As such, friction depends upon the nature of the two surfaces and upon the degree to which they are pressed together. The maximum amount of friction force that a surface can exert upon an object can be calculated using the formula frictional force is equal to friction coefficient multiplied to the normal force, wherein mu is the friction coefficient and it can be a sliding or static friction, and Fn is the normal force. An applied force is a force that is applied to an object by a person or another object. If a person is pushing a desk across the room, then there is an applied force acting upon the object. The applied force is the force exerted on the desk by the person. The symbol for it is FAPP. The tension force is defined as the force that is transmitted through a rope, string, or wire when pulled by forces acting from opposite sides. Every physical object which is in contact exerts some force on one another. If one of the force exerting object is a rope, cable, or chain, you can call it as tension. Tension force formula. The tension on a body can be expressed numerically as T is equal to mg plus ma, where T indicates tension with the unit N for Newton, m indicates mass with the unit kg for kilogram, g indicates gravitational force which is equal to 9.8 meter per second squared, and a indicates acceleration with the unit meter per second squared. Tension in the rope must equal the weight of the supported mass. As we can prove using Newton's second law, if the 5 kg mass in the figure is stationary, then its acceleration is 0, and thus, the net force is equal to 0. The only external forces acting on the mass are its weight, W, and the tension, T, supplied by the rope. Thus, the net force is equal to T minus W is equal to 0, where T and W are the magnitudes of the tension and weight and their signs indicate direction, with up being positive here. Thus, just as you would expect, the tension equals the weight of the supported mass. T is equals to W is equals to m times g. For a 5 kg mass, then, neglecting the mass of the rope, we see that T is equals to m times g is equals to 5 kilograms times 9.8 meter per second squared is equals to 49 Newton. If we cut the rope and insert a spring, the spring would extend a length corresponding to a force of 49 Newton, providing a direct observation and measure of the tension force in the rope. Here are some examples of tension force.